Hi, I am Pasuduka Havidana. Welcome to my channel. In today's documentary, I am going to discuss about the biggest shift in the AI industry which is happening right now. Let's jump into today's video. For most of the human history, tools were weighted. If we consider a calculator, it's produced nothing until human hand pick it up and doing any kind of calculation. The same behavior applied for artificial intelligence also for a decade. It's producing answers when human giving any kind of prompt or human asking any kind of question from it. When human stop asking, it's stop responding and it is going to idle state. When human asking or when human interacting with it, it is producing. When human stops, this LLM or this AI model also stop producing. Between the time period 2021 to 2023, this AI was co-sophisticated predictive engine. It has huge potential. When we asking something, it is producing. It can be text output, it can be video output, it can be audio output, anything. It is analyzing our question and giving responses. It is having huge potential, but it is producing only when we are asking something. The machine was powerful, but it was passive. Meanwhile, the world is drowning. If we consider the banking sector, there are manual fraud detections, manual fraud analysis. And if we consider hospitals and healthcare industry, there are manual login of patient details, insurance handling. All of these things are overwhelming human employees, and enterprises are allocating billions of hours to doing different coordination between teams and doing some kind of repetitive tasks. They are allocating billions of hours and billions of employee hours on these repetitive and non-cognitively demanding tasks. In one side, there is a passive tool which is having huge potential. In other side, whole world is drawn in with huge workload. Now the demand was clear. We not need any kind of smart search engine. Yeah, it's nice to have a smart search engine, but it is not the target from this kind of AI with huge potential. It is not the target anymore. World needs something, some system which can pursue any kind of goal, and according to that goal planning different actions. Based on planned actions, it should be able to work on those actions or acting on those actions. According to the result, this should be able to learn from those outputs and corrected itself. We need that kind of system, and human intervention should be minimum. Always not need to human to intervene and doing changes in there. This tool should be able to do works from itself and corrected itself and learn and again acting. This should be possible. Based on that demand, in 2021 to 2026 time period, AI was not improved. It's actually changed from what it fundamentally was. This is the story of that transformation.
An AI agent is not a chatbot with more features. By 2025 to 2026 definition, it's a system combining large language model with additional capabilities. These are tool access, memory, and routing logics, together producing something categorically different from prompt and response engineering. Okay, here further in this earlier case, traditional case, also there is large language model, but the difference in here is further to that large language model there is tool access, which means it can pursue its environment and maintaining kind of status memory and uses tools, APIs, and dashboards, and there are routing logics. But in earlier LLM, in earlier chatbots, it's just a standalone LLM. That autonomy runs on 4 stages. So we are calling them as agentic cycle. As I mentioned earlier, since there is some additional features in agentic AI, it's based on these agentic cycle. It's initially it's perceive, which means ingest data from APIs, documents, and live environments. After ingesting those details, it's reason, which means decompose the goal into sequential subtasks, and according to those subtasks, then it is acting. And after acting, it's which means executing according to the plan, it is executing. After this action, it is learning, which means after this action there is kind of output. based on that output, if it is correct, it is learning, this is the way to execute. If it is wrong or incorrect and it is learning, this is not the way to continue. The cycle is the core separator agents maintaining status and verify their own work, which is something no prior AI systems were capable of doing. This is why it is, according after this learning, it is keeping some kind of status. Then it is improved. Then again perceiving the environment, and then according to the environments and goal definitions, it is reasoning. After reasoning, it is acting based on plans, and then again learning. Then it is in another new state. Then again this loop, this cycle is happening, and continuously this AI system is improving and learning. Agents handle uncertainty using two reasoning mechanisms. They are chain of thought and tree of thought. In chain of thought, it is sequential mechanism, and it is a before getting any kind of response or doing any kind of action, there is a chain of thought according to the goal. Then the step one is this, it's analyzing something, and then step two is this, it is searching through some databases and giving answer, kind of thing is there in chain of thought. In tree of thoughts, according to the goal, it is simulating multiple parallel paths. According to the goal, it is defining few paths, which means what are the next actions, and simulating each of these action before taking any kind of action. It is simulating purely. And after simulating, according to the simulation results, it is selecting the best path, and it is executing, acting on that best path. The domain-specific agents are consistently outperforming general models, constraining the toolset strings and decision space, which makes reasoning both faster and more precise. If we use some kind of generalistic agents, the decision scope is real. It has to simulate multiple paths. There can be different steps are there, have to simulate and think about all of these things, and then it can be give some hallucinated outputs. Further to these things, there is documented risk also. Failure modes are real and well documented. First thing is hallucinated actions. In hallucinated actions, as earlier also we saw that hallucinated results in those AI chatbots. Similar to that, there can be hallucinated actions also, since agents are also based on large language models. As example, those agents can try some non-existing API. It's know that there is no any API, but try to connect to that non-existing API. Yeah, that is some kind of hallucinated action. And similar to that, there is other issue can be there. Those are the infinite loops. In infinite loops, so it is occur when agent getting completely wrong direction, and then it got wrong results. After that, it is doing some slight changes here and there, but still the direction is wrong, and doing some kind of slight changes, and then again watching for the result. Then it is confined into some kind of loop and doing similar things with slight changes, and then it is kind of infinite loop, and then user should interfere that and can manually kill that process. So actually human should be involved in that case. These are the two main failures which can be happen. First thing is hallucinated actions, and second one is infinite loop. Yeah, in the next case, I'm going to discuss about why earlier also I have mentioned one generalistic agent is not enough. There should be more specific subject specific agents. As example, you can see here, if there is one generalistic agent, and it has to search through database, do queries and retrieve data, and it has to go over the different web pages and do web scraps, and it has to do researches and going through different APIs and do researches on there, and it has to act on CLI and install different environments and coding activities, scripting things, also everything these generalistic agents have to do. Human also, we know that if we are going to do everything at once, our memory get lost. In here also, in generalistic agents, there is something called context window. In there, context window can be overused in these kind of situations and increased. Then it's actually context window is kind of whiteboard kind of thing, and it is filling with these different tasks and actions. When it is going through everything and doing everything, this whiteboard kind of thing is completely filling. Then when getting another information and any kind of data retrieval and any kind of input from user, then after that context window filled, it is deleting some old things. Then while those deleting process, it can delete some kind of information rule, important rules or information, that process is required, then it can be lead to hallucinations in results or actions. Yeah, that's why generalistic agent is not enough. It is some then in kind of conflict tasks, it can be really overwhelming. To as a result for that, there is a multi-agent orchestration architectures. There is some master node. It is really good thinker, and according to the task, it is creating separate agent for command line interface related activities, scripting, or creating any kind of backend function and those things. That node is specialized in there, and it is feed with required data sources and require it is connected to required mcps and like that. And there is another agent. It is its responsibility is to go through databases, retrieve data, and load data. Yeah, those are the things, responsibilities of that. For other agent, its responsibilities go through internet and search things and getting details and informations, fetching those informations and giving report kind of thing is the responsibilities of that agent. Each of these agents are specialized only in that task, and it is really efficient in each of these tasks. Then that task is without any hallucinated action or result, that task can be done. Further to that, the speed is also high because in parallelly and separately they are doing their own task. Sometimes it can be wait for others response also, but they are parallel doing their task with their expertise. According to the Gartner's enterprise inquiries about multi-agent systems, it has surged 1,445% between the Q1 of 2024 and Q2 of 2025. Now, that number reflects not only curiosity but genuine urgency to solve real-world operational problems, because enterprises were started to using those agents, but similar when using single agent, and that agentic hierarchy is not suits for their organization structures, then they are rising coming up with different issues. That's why the inquiries are raised in this period, because organization started using agentic architectures. While using this, those multi-agent requirement is coming up. As example, if we take hospital system, surgeon is doing operations, scheduling, booking doing by the required staff, and billing also the required staff and nurses, and taking care in of patients. And like in here also similar way, orchestrator coordinates, and it's a good model with planning capabilities, and research agents are gathering information, analytics agents are processing some scripts and analyzing those data, and synthesis agents are completing final outputs. Yeah, this is well organized, and if there is an issue, and it's easy to trigger, and there is specialist agents to do each task. There are 6 ways to orchestrate AI agents. Six, we can say this as 6 core patterns define how agents are organized. We will go through each pattern in deep. First thing is coordinator worker pattern. There is a primary agent delegate to specialized sub agents, and simple to set up, but coordinator becomes bottleneck here if these created worker agents always giving some kind asking some kind of response or some kind of permission, some workers giving some results and have to check those results as well. And then here this one coordinator agent can overwhelm, and it's becoming kind of bottleneck, because this agent should have better performance to handle all of these worker agents. And here, but there is some situations we can use this architecture as well when there is not much workers, and workers taking time to do any kind of process, and coordinator have to wait until they are completing. Yeah, this is for as a basic architecture, this is really good architecture. And the second one is hierarchical teams architecture, best for actually its agents are structured like corporate departments. Manager agents are there, they are overseeing research agents and writer agents, and strict reporting lines. Each one has time to time give update to these manager agents. Yeah, that kind, if it is any kind of complex task, this kind of hierarchical team architecture is better. And the third one is sequential pipeline. It's a data process. As example, if you are kind of ETL process, data ETL process, these things should, when the things should be happen in sequential way. As example, in ETL, initially extracting data, and in again it is transformating those data like in normalization or any kind of encoding, and then coming up with results and loading them to a database. Yeah, this is sequential process. Always before loading those data, it should be normalized, and before normalized data should be fetched and pre-processed. Yeah, this is sequential thing. For this kind of thing, there we can use sequential agentic architecture, sequential pipeline. Then the next thing is parallel fan out. It's a multiple agents execute the say different processes in parallelly, and the input is given, and it's each of processes divided to these different agents, and those agents are parallelly working on each of these assignment, and they are giving their output, and according to those output getting final conclusion and final synthesis. And the next one is conversation based architectures. Agents are converse freely until the consensus is happen. It is highly flexible, but it is some kind of messy, you can see that. And also it is hard to difficult to debug issues also due to this undeterministic nature. But in any kind of high conclusion required consensus systems, you can use these kind of architectures. Have to have good some kind of governance structure to control these kind of group chat kind of conversation based agentic architectures. Then the final one is plan and execute architecture structure. It's there is a planning agent. It builds a static blueprint of cheap execution agents are following that blueprint. This is some kind of higher agent with higher capabilities, higher planning capabilities, and reasoning capabilities. And for one time it is creating blueprint and plan and assign according to that, creating different agents, low cost agent we can say it as, or very basic agents, and plan is already created, and according to the plan it is created different agents, and agents are work according to that plan. And in the middle, these agents are not going to change that plan nor reasoning anything, they are just acting on its own work, and after that it is coming up with final results and sending them to this planning agent. In meanwhile, they are not going to do any plans and change of direction. Those things are not doing by these agents, worker agents. They are just simple agent without having much capabilities or reasoning or planning abilities, so they are just doing their work. And in this kind of architectures, the token cost is also really low, because those agents are not having much capabilities, but they are specialized in the task they are doing. And only cost is this planning agent is only having more reasoning and planning capabilities, and it is having those features, and only that agent is high cost agent and others are low cost agents. And most of current industries and enterprise level, we can see that these kind of architectures to control cost and optimize between cost and performance. When we are talking about agentic AI and multi-agent architecture, we can't forget this MCP, Model Context Protocol. Actually, this Model Context Protocol is connective layer or connective tissue that hold all of these together. Yeah, agents and different databases, browsers, code terminals, and external APIs. Yeah, this is the layer in between this. Actually, it's connective connection layer or connective tissue. It's kind of USB interface in electronics. We said that in earlier, for audio output we are having different audio jack, and for speakers we had different jack, and for mouse, keyboards, and those of things we had different jack types. And after USB come into picture, for our laptop or our computer, all of these mouse, keyboard, and everything, monitor, or any monitor, audio jack, or anything, we can connect via that USB port. This MCP is also similar to that for different agent. As example, this agent can be, one agent can be some Anthropic agent, Claude agent, and one agent can be Google agent, and other agent can be OpenAI is a GPT agent. Yeah, this can be any agent. All of these different kind of agents can use same protocol or same interface for protocol to connect databases or do web searches, web browsing, or code terminal access, or calling external APIs. Yeah, this MCP is kind of mid layer. Actually, it is the MCP's emergence in 2025 to 2025 period directly unlocked enterprise scale interoperability, different agents, or this connected together different API providers, different service providers with various agents. Before it, actually, before the MCP, there were some custom built-in APIs or custom built-in protocols different APIs has used, and agents can autonomously discover and adapt new tools. That period, adapting new tools and services natively is really hard. But after this MCP coming, there is a common in between layer, connective tissue. Different agents can, all of these kind of various agents can access these services with this MCP.
Autonomy without a governance is not a feature, it's actually a liability. Consider this kind of agents. which is having access to different databases, having various credentials of the systems, and having mission critical database or API accesses, and they can do transactions, and they can do code changes. There are huge potential inside this LLM, and it can act on different APIs and databases, and it can do changes. Imagine this kind of agents who are having access to mission critical databases or in internal proprietary informations, and they can do transactions, and they are having huge capability. When this kind of agent is in there without proper governance, it's a real vulnerability. Traditional cybersecurity measures can do nothing with this kind of new issues. The threat is no longer data breaches. The threat is this autonomous capability abuse.
Here you can see the expanded attacks phase. Here I'm going to discuss in detail about these attacks. The primary risk is till now is not data breaches anymore, as I mentioned earlier. The risk is autonomous capability abuse. The first thing is we are going to discuss here is indirect prompt injection. Here the thing is happening. Here we can see these research agent in here, and here this is the enterprise's premises, our enterprise premises, and this research agent also working in here. There are some mission critical databases, and there can be some proprietary details or anything. Yeah, while this research agent is doing research, we know that research agent is going through different web pages, and inside one web page there can be crafted external document that contains some prompts which can this agent can be mislead. With that prompt, there is prompt to this agent, go here and go to your enterprise database and get these details and send them back to me. Kind of details, kind of prompt can be there. Actually it's not direct prompt, but according to the prompt it's some kind of it can be a structured prompt, which this agent can be indirectly prompted with that injection and override their primary directive, because from planning agent this research agent got some kind of direction, but with that information or prompt in this inside this web page, it can be mislead and give some kind of sensitive information to this web page or their API can. So there is some direct prompt injection related risks can be associated with there. Then the next threat type is credential sprawl, which means the agent need API keys and database access to do their functions. So compromising one agent's grants laterally movement across entire enterprise network. Actually, one breach can lead to many breaches there. So here you can see that based on this threat 1 and threat 2, credential related threat, and indirect prompt injection related threat, we can see that these autonomous capabilities can be abused. So that is the main risk factor in these agentic AI and multi-agent architectures. Now we have seen that there are some security vulnerabilities associated with these agentic models, and we saw what are those things. And then to build trustworthy systems, there are few KPMG's governance frameworks. One thing is giving machine identities. Here it's giving Kubernetes workload identities to each agent, and the next one is having some kind of privilege limits for each agents, and each agent having privilege limits to access different databases and internal resources, and as well as each agent having machine identities. According to that, we can control access. And further to that, secure by design, actually it's goal positioning. It's actually the design is architectural level each agent, which means while providing skills or roles, and when creating each agent architecture, we can define that some security measures inside each agents and how they should behave and what their goal should be, and this goal should not be poisoned by any kind of external factors. And further to that, there are agent check-in agentic workflows also. First thing is automated, it's quality assurance kind of thing. This agent A is doing some kind of action, and agent B is a reviewer, and it is evaluating that agent A's action according to some kind of measurements and with some kind of tool sets. And if its evaluation passes, and only if the evaluation pass, it do that action. Actually here, further to that security measures, the quality improvement also can be happen, because this agent B can check the standard quality level, the requirements are matched, all the thing can be checked by this second agent. Further to that, there is a consensus mode also. It deploys multiple independent agents on the same task simultaneously, and action is only taken when majority of them reaches the same conclusion. Actually, with this, if as example, this agent node 1 and node 2 giving the same result, but node 3 giving wrong result, different result, then with that different result will be rejected, and result will be the majority result of majority of the agents. Actually, due to these kind of things, the quality of results also significantly increased, and reliability also becomes mathematically demonstrable. Then we consider the economic transformation. Despite of all these challenges, development is accelerating. High margin data rich sectors like banks are running multi-agent swarms for real time in fraud investigations right now. Further to that, in healthcare sector also there are systems agents using for complex patient scheduling and billing reconciliations. There are production systems. They are not pilot or any kind of things. They are production systems. The economic logic traces directly to this Ronaldo Coes theory. According to that theory, which is around 1937, Ronaldo Square's theory of the firm, the primary cost of running organization is not production according to that theory. It is coordination cost. And agentic AI reduced that coordinational cost to near zero margin expenditures. Here we can see that between the 2023 to 2026, the coordination cost, the organizational cost is reduced to near zero margins due to these agents, because coordinating different departments or with customers or handling different kind of transactions, those are things can be automated via or agents. And human involvement, we know that will place in sales call or something, the agents are not thinking before doing. Actually, humans are procrastinating and they don't like rejections, but agents are not so. They are generative engines. So due to that, these coordinational fences, we can see that they have reduced. Yeah, we know that still there is barriers in industry. They are real, but there are like barriers like technical depths and regulatory uncertainties and unstructured data sets and inference costs. There are some issues are there, but with those issues, the organization has been able to, as I mentioned earlier, that plan and execute patterns are there. That is actually a cost effective pattern architecture. Yeah, the organizations are moving to those kind of architectures right now and minimizing redundant reasoning cycles. And this IDC forecast that 40% of global 2000 job roles, from 2000 job roles locally, 40% of them currently will, actually this is not talking about 200 job employees or kind of things. Here we are talking about 2000 job roles, not employees. From 2000 job role, 40% of those 2000 job role are currently involved in managing these kind of agents or working alongside with these kind of AI agents, which mean AI agent colleagues with working with AI agent colleagues by 2026. This is the current measurement, not any projection or prediction. In according to the current measurements, there is 40% of reality. These agentic platforms positions humans not as operators but as architect. Human in the loop model places human at the directive layer, defining goals, setting boundaries, and intervening when agents exceed their confidence thresholds. Yeah, predictive models determine the optimal intervention timings. Yeah, there is threshold limits when this confidence level is exceeding. Always these agents escalating things to human who is in the loop. Yeah, human is kind of architects here. The workers working under him, calling him when their confident threshold is exceeded. Yeah, actually, currently we are having some brand new career categories as well, some emerging job roles also with these agentic and multi-agent architectures. They are AI governance specialists and human in the loop coordinators, agent architects, and AI ethics related specialists or orchestration designers and prompt engineers. Yeah, like that. There can be many roles in the future. Current now, these kind of roles are there in the industry and corporate level. The displacement of entry level knowledge work is real and it's documented, and also the creation of high order roles requiring human judgment, human cognitive abilities, and ethical reasoning and strategic directions. Yeah, both are the things are true simultaneously. There will be more roles and displacements as well. Okay, then I'm going to do some kind of demo using the things we have studied. Actually, the agentic and multi-agent architectures, how they are we can simulate those things in real world, or we can actually do those things in real world. Here I have used Claude Code application, and before going to demonstration, I will give you some kind of quick overview. Here I'm asking from my main agent, which means orchestrator agent, to do a research in latest AI model capabilities from Anthropic, OpenAI, and Google. Here this agent, in simply here, this is the orchestrator agent, and it is getting my prompt. I am the architect here, and I am giving my prompt to this orchestrator agent. Then according to my prompt, it is creating 3 separate research agents, one for do research on Anthropic AI products and AI models, and one for OpenAI related things, and another research agent for Google AI related research. Then after doing research, they are going through all the documentation, online resources, and documentation of their official web pages and user reviews and all of these things. They are going through all of these things and finally coming up with this kind of some kind of report, the MD file, Anthropic MD and OpenAI MD and Google MD. And then this orchestrator create further to these research agents. Then orchestrator creates some kind of data analytics agent, and that data analytics agents consume all of these MD files based on their researchers and compile, synthesis those results and review those things, and then finally deliver a comprehensive report. Yeah, that's the what here happening in this demo. Then yeah, we will go to that demo with Claude Code. Here I have opened Claude Code for the demonstration. Here I will give my prompt. Actually, in this prompt, there is nothing more than just a simple explanation on what I need to do. Research the latest AI model capabilities from Anthropic, OpenAI, and Google in parallel using 3 separate sub-agents. Here I'm asking to create 3 separate sub-agents. And each researcher should use web search, web fetch, and write finding with source URLs to research, which means OpenAI, Anthropic, Google.md file. Yeah, each this agent should write findings into the text file and return only short summary. Then compile key benchmarks. Here as benchmarks I have used SWE benchmark, which means software engineering benchmark. It is a giving kind of bugs in GitHub and asking this model to solve those issues, and according to the actual passing rate, which means resolving rate, it is that benchmark value is given. The second one is GPQA. It's a kind of QA task, which means reasoning and to check reasoning and planning abilities. Yeah, here that also I have given. Then the context window, I have already discussed about this, the context window of each model and the price of those models into data benchmark.json file. Then have a data analysis sub agents, write a script and using pandas and matplotlib to produce bar charts and figures and run it. And finally write synthesize report comparison report MD with executive summary, a comparison table, and the chart and recommendation. Yeah, that's the prompt I have given. I have asked to create sub agent to do separate research and compile one agent to analyze them and compile final report. Then here I will use Opus, since here actually it's not need to have Opus on it is enough. Generally this kind of task, initial planning task, we are giving some model which is having some better planning ability. Here for demonstrate I will give Opus 4.6 and then send it. Now it is thinking and allow to create those directory architectures. Now creating these agents. Yeah, while creating agents, here we can see how they are created and tokens they are using, tools using, web search, how many tokens are used. Yeah, there's one agent is researching on Anthropics, one agent is researching on GPT models, and another agent is researching on Gemini models. All 3 research vendors are running. Yeah, this is will take some time. I'll come back when after these 3 agents completed their tasks. Yeah, one agent has completed its work. Other 2 are still working. 2 were completed. We can see their results and those in summary. Yeah, dollar rates and yeah, the things are mentioned in this research document. Yeah, now analysis agent is running. Yeah, here we can see that next agent has created data analysis and visualization agent. We can see that it is all of 3 agents used around 1 minute time frame to complete, around 1 minute. Yeah, if we sequentially run, if we run one agent, yeah, we can see that when we are running multi-agent, time also improves. We'll allow this. Yeah, asking to. Yeah, now all 4 agents are completed. All charts were generated. Final synthesis report is creating. Now all four agents have completed their task, researching part and data analysis and visualization part, and now in final stage of creating final report. Yeah, now these are the outputs. Yeah, we can see here the research, each research output files, and data analysis Python script and JSON files, and all of these figures. We will see how the final report look like. Yeah, it is a model capability comparison report. Yeah, it's really nice. It is comparing all of these models based on different factors which we have provided. It's a really comprehensive document, yeah, based on all the research elements and everything. Yeah, it's a really comprehensive document, and there are some figures also created. Yeah, this is for SW. We can see that Anthropic models are performing better there, and then OpenAI models, CQA, yeah, there are also Anthropic models are performing well. Price in comparison, yeah, and both all of these here also you can see those models are performing well. And context window, yeah, Google is better in that. And this is the final report. Yeah, this is the final thing. All the required details are there, and this is a comprehensive research report with all the figures and comparison details. Everything is there. Yeah, yeah, that's the thing I just want to explain. I, as an architect, I have given the prompt. Then my orchestration agent creates separate different agents, sub agents, and based on the specific task. And yeah, here we can see that there are different architectures, agentic architectures. We have followed the, yeah, this is the final report we have get. Yeah, that's it for this demonstration, short demonstration. Yeah, from that demo, I think you got a good understanding about those things which we have mentioned throughout this video. And with, as a final note, I have to say is there should be good architectural design, and there should be security governance, and human oversight should be there. Then we can increase success rate in this kind of agentic AI and multi-agentic AI systems.
2026 is not the year agentic AI was promised. It's the year it has actually arrived. Agentic AI and multi-agent orchestration is not any kind of roadmap in the industry. It is what actually happening right now in the industry. Most of workers, most of employees working together with AI agents. Some of employees working or managing several AI agents. This transition has already happened. That passive AI system now become multi-agent systems which is perceiving goal and reasoning and acting and correcting and learning itself. Now this is the system which is organizations are following, and this is the current state of the industry. This co-evolution need AI governance, human in the loop architectures, AI agentic specialists, AI ethics related specialists. So there are opportunities. If we consider the history, every technological revolution created more opportunities, opened more doors than eliminated. Yeah, not immediately, not without a friction. It will take time. But anyway, this will open new doors. This will open new opportunities. Yeah, there can be displacements. There can be eliminations. Yeah, now the door is open. Entry does not require mastery. It only requires the direction and the focus. The question is not whether AI will reshape the global economy. That question is settled right now. Now already AI has reshaped the global economy and is still reshaping. The question is who helps, what will it become, who helps to this reshaping of the future, and who are going to reshape their futures with this AI revolution. Yeah, that's the question. That's the wrap up on today's video. If you get clear idea about where AI is heading and what is the current status of agentic AI and multi-agentic orchestration architectures and where you fit in this industry, I think you have taken some kind of idea where AI is heading right now, what is the current status of that, and where you going to fit in this industry, what are the skills you are already having, and where you can apply those skills in current status. And I think you get some kind of idea. And don't forget to share this video with someone who needs to hear this. Subscribe to my channel for more breakdowns like this. See you in the next one.